Hi, welcome to the Shiko Math Lab. And for this video, we're going to take a look at how to find the volume of a solid torus. So what is a torus? Torus is basically, it's a kind of like the donut shaped solid here. All right. So now let's take a look how we do that. So here we go. Here we want to find the volume of this solid torus. And then here is the graph here. So like we always mention here, when we try to do the slicing methods here, the first things here we try to do is we will try to find the x-axis and the y-axis here, all right? So this is my x-axis, and then I'm putting my y-axis here. Okay, so now in here you can see these circles, right? So this circle, so it's kind of like this is the solid was generated by you are rotating this circle along the y-axis, right? So if you're moving this circle, the circle's area, then you're moving around the y-axis. That's how do you the generator, this is solid here. So let me try to put the, put the colors. So like, for example, this is the circle, we are working on, all right? So you are moving this circle, rotating about the y-axis here. Okay, so now let me try to put this circle into a two-dimensional place, and maybe you can see better. All right, so this one's here. This is my y-axis, this is my x-axis. Okay, so take a look. From the center of here all the way to here, we say this is the big R. So that means the circle will start at this point. This point is the R and the zeros, right? So it's the x value is R and the y value is 0. And then I have a circles here. So I move that circles to here. All right, so this is my circle. And then here is my radius, right? So here's my radius R. Okay, so now let me try to write by the geometry. We know how to write the formula for the circle, right? So right now my center of the circle changed to the R and the 0. So the formula will be x minus R square plus y square equal to what? Equal to lowercase r, right? And because it's around, it's circling around the y-axis. So I want to integrate to y. So that means that solving the x for y function. So x squared minus r squared is equal to the r squared minus y squared. So x minus r will be equal to the square roots of the r squared minus y squared. Also, the x minus r could be the negative r squared minus y squared, right? So when we take the square root, we can have the positive or negative square roots. Okay, so now let's simplify. So this will be the x equal to r squared plus y squared, right? Then plus r. And this one's here will be the negative r squared minus y squared plus r's here. So if I add these functions here, I will call this function. If I say, hey, this function, I call this is f of y functions, and I will call these functions here, this is like a gy functions here, all right? So let's take a look where is my fy's here. So my fy, okay, so take a look at my fy's here, right? So it's the positive r squared plus y squared plus r. So that means the plus r is here. So this will be my fy functions here, right? So this segment is here. This is my fy. Okay, and then the same way, so the x equal to the negative r squared plus r equal to the gy. So here, this one will be my, here, this will be my gy functions, right? So this is will be my gy functions here. Okay, and then now, okay, now here, okay, so now we are cross sections, right? So we are cross section, and so the cross sections here, so then the volumes here, take a look here, right? So the volumes here will be, okay, so will be from the volumes here will be from the y to here, hold on. Okay, so here, okay, so now I think here, let's, let me, okay, so my gy is really is all the way here, right? So here, so this half, and that's why here, this is f of y. Okay, so now my function, my volume will be, because it's rotating around the y-axis, right? So volume will be pi r squared. So here, then take a look at my pi r. So the first r is here, right? So let's take a look here. So the first r, so you like in here. So this is my outer radius. I'm going to minus the inner radius. That's why I'm going to get the, the areas in betweens, right? So this is inner, and this is the outer radius here. Okay, so now here, okay, so like pi r squares, right? So it's pi r is all the way from here to here, right? So it's f of what? Y square minus the inner ray, so it will be gy what square, and do the dy. So what is my y value here? Y value will be from what? Y value will be from here to here, right? So here, this is 0. So this is negative r to the top here. So what is here is r's, right? So it will be the negative r to r's here. Okay, and now after you set it up, then the remaining will be pretty easy here. So then this one will be pi, then this is negative r to r. F of the y is here, right? So it's the r squared plus y squared plus r to the square, and minus the gy is here, right? So this is negative, right? So this will be the negative r squared plus minus y squared plus r, the whole thing squared dy. And then we notice also this is y squared and y squared, all the lowercase r and uppercase r, they are all constant, right? So we know this is even function. So if it's even function, I can simplify it here. I can say it's 2 pi. So will be from 0 to r. See here, right? So that I can simplify it because it's the even functions here. So that's why I have the 2. Then instead of from the negative r, I will have from the zeros, right? Why is because of the even function. When I do the integration, I can simplify just times 2. Okay, so this will be the 2 pi from 0 to r. Okay, so now let's just, distribute this one. So this will be the r squared plus y squared. All right. So r squared plus y squared plus 2ab. So it's a 2r, r squared plus y squared plus capital what? Capital R squared. That's right. Capital R squared. Okay. And then minus here. Minus here, right? So still you just FOIL it. So this is the r squared. Sorry, this is a plus. Okay, so this is the, this is minus here. Okay, so yeah, that So here, okay, so I did here right. So here this is minus, minus. I need to be careful for that. All right, so this is minus, minus, okay? So this will be the r square minus y square, and here, okay? So I need to be careful. This is r square, and this one is also r square minus, yeah. All right, okay, so this is r square minus y square minus 2r, because I have a negative sign here. Okay, so minus 2r, then the r square minus y square, then what? Plus r square, right? That's what we FOIL out the square terms here. Okay, so now this one will be 2 pi 0 to the r. Okay, so now let's simplify that. This is r squared minus y squared plus 2r, and this is r squared minus y squared plus r squared. Okay, now minus, okay, so distributed minus r squared minus minus is a positive y squared, minus minus is a positive 2r, r squared minus y squared minus plus minus r squared dy. Well, let's take a look how many things we can cancel here. So here we see like r squared, y squared, y squared, r squared, r squared. Okay, so now what do we have here? This will be, this is the 2 pi and 0 to the r, and how many r's? 4r and r squared minus y squared dy, right? From the 0 to r here. And now let's see here. Okay, so now in here, okay, so we have this one is 2 pi 0 to r. So if I want, I can take the a pi r out, right? So this is the 0r r squared minus y squared. Okay, so this is r squared minus y squared dy. Okay, so this is the r squared minus, okay. So now let's take a look at what is this terms here, all right? So let's take a look at what is this term, 0 to the r squared minus y squared dy here. Okay, so let me go to here. So, okay, so let's see here. Let's go to the next page. Yeah. All right, so let's see what is this one. So 0 to the r squared minus y squared here. All right, so this one's here, if you take a look at this is our, okay, so if this is the circles, right? So if this is the r, right? So then the x values here, right? So this is my x value. X is equal to the r squared minus y squared. So if you have r, if you have a circle like this circle is x squared plus y squared equal to the r squared. So you can simplify the x, right? So that you can say x is equal to the r squared minus y squared. So what is the r squared minus y squared? So it will just be what? You know, it's the x values, right? So it will just be this part, right? And then you integrate from 0 to r. So you integrate from 0 to r. So what is this blue one is really is what? I'm integrating from that. So it's what? It's the area, it's this blue area, correct? And what is this blue area? So I know the 0 to r, and this is r squared minus y squared dy is what? It's a quarter of the area of a circle, right? So what is the area of this circle? It's a pi r square. And because this is a quarter of it, so this numbers here is what? Is pi r square over 4. Right, so this is a pi r square over 4. So now let's substitute back to what we just find is here is a pi r, right? So now we know the volumes here is a pi capital R, then this one is 0 to r, this is r square minus y square dy. So I know this is just a part of the quarter of the area. So this is a pi r times 4 pi r square. Okay, so now let's simplify it. So this is 4 and this is 2. So what is the final answers here? So the final answers here will be 2 pi square and r square and capital R. All right, so this one is a little bit more complicated, but okay, so we still use the similar idea. So the last one is here, the last step, this is kind of tricky, right? Because we said finally, after that, we finally get the volume is a pi r, and then we still have this integration, 0 to the r squared minus y squared. Then we say, what is this one? Then we said, if you look at circle, right? R squared minus y squared is the x values here, right? So that means you are slicing, right? So that's what this is, the x values here, right? So that means you are slicing like this way. You are slicing like this way, right? So that's y is, so x is equal to what? R squared minus y squared, right? And then you integrate it from 0 to r. So you get only this quarter of the areas here. All right, that's it. I hope this help and good luck. Try to, maybe you can try to do it, by yourself after watch the video to see you be able to reproduce it or not. All right, that's it. That's it for this video, and we will take a look at some other problems. All right. Okay, nice talk to you. Talk to you later. All right, bye-bye.